Alright, today's lesson is 5-9, day 2. We want to be able to identify parallel and perpendicular lines. We want to be able to write equations in slope-intercept form of parallel and perpendicular lines. And we're going to complete 2 geometry applications of this in class tomorrow. This is just a little bit of a review. You do not have to write this down. I'll let you know when you need to start writing. Parallel lines are lines that have the same slope and do not intersect. There are lines in the same plane that do not intersect and they have the same slope. We talked about this in your video yesterday. If I look at the slope of both of these lines, they're exactly the same. They're both 5/3, so they are parallel. And that's how we know that they're parallel, is because they have the same slope. It says all vertical lines are parallel lines. Perpendicular lines are lines that intersect and form right 90-degree angles, and they have opposite and reciprocal slopes, meaning one's positive and one's negative, and you have to flip the fraction. And it says the product of the slopes is -1, meaning that if I multiply them together, I should always get -1. And this is an example of that. Notice that these two lines cross and they make a 90-degree angle right here. If I look at the two slopes of these two lines, the slope of this one is 5/3, and the slope of the other one is -3/5. Again, one's positive, one's negative, one's 5/3, one's 3/5. They are opposite and reciprocal. And again, this part right here is just showing that if you multiply them together, you get -1. And it says vertical lines are perpendicular to horizontal lines. It says tell whether each pair of lines is parallel, perpendicular, or neither based on the slope. You don't have to write these down. We have y equals 1/2 x plus 5 and y equals 1/2 x plus 6. We looked at this yesterday and we said, okay, we're going to look at the number in front of the x because that's my slope. And we're going to say, are they the same, are they opposite, reciprocal, or are they neither? And here, both of the numbers in front of the x and both the slopes are 1/2, so they are the same. So they are parallel. They have the same slopes but different y-intercepts. Now if we look at this one, y equals 4/5x minus 9 and y equals -5/4x minus 1. Again, I'm going to look at the number in front of the x when it's in y equals mx plus b form. Looking at the number in front of the x, we're going to look and say, okay, these are opposites because one's positive and one's negative, and they're flipped. So they are opposite and reciprocals, so they are perpendicular. Again, perpendicular have opposite reciprocal slopes. And then we have y equals 7/8x minus 3 and y equals 8/7x plus 2. Again, I'm going to look at the slopes here and decide are they the same or are they opposite, reciprocal, or neither. They're not the same because one's 7/8 and one's 8/7. They're also not opposite reciprocals because they are reciprocals, however they are not opposite. They are both positive. So this one would be neither. The slopes are reciprocals but are not opposite. Alright, here's number 1. This is where you need to start writing. We're going to tell whether the lines, if this pair of lines is parallel, perpendicular, or neither based on the slope. So go ahead and write down number 1. 4x plus y equals 0 and y minus 3 equals -4 parentheses x plus 2. Now for both of these, this is a little bit more difficult than yesterday. Yesterday they gave us the problems in y equals mx plus b form. Today we're going to have to make them look like y equals mx plus b before we can tell whether or not they're parallel, perpendicular, or neither. So if I look at this first one right here, I need to get this y by itself, so I need to move 4x. So I'm going to subtract 4x from both sides and say y equals -4x. If you want to put the plus 0 on the end, you can, but you don't need to. Over here, to get the y by itself, I'm going to have to distribute my -4 first. So I'm going to say -4 times x is -4x, and -4 times 2 is -8. And you can write that as plus -8 or -8. Then my y still is not by itself. I need to move the -3, so I'm going to add 3. And y equals -4x minus 5. Now that both of these are in y equals mx plus b, they look exactly like the ones that we did yesterday and the ones that we just looked at. We're going to look at the number or the m or the slope in front of the x, the number in front of the x, and we're going to say are they the same, are they opposite reciprocals, or are they neither. And here they both have -4 in front of the x, so they are parallel because they have the same slopes and different y-intercepts. So make sure that you write parallel, same slope, different y-intercepts. Make sure you have all this written down before you move on. Number 2, go ahead and write this one down. Y plus 6 equals 5 parentheses x plus 1, and 5y equals negative x plus 10. Again, we have to get both of these in y equals mx plus b form before we can tell whether they're parallel, perpendicular, or neither. If I were you, the first thing I would do is this negative x right here. I would put a little 1 in front of that x. On this side, if I'm going to get the y by itself, I first have to distribute the 5. 5 times x is 5x, and 5 times 1 is 5. Then I need to move that plus 6, so I'm going to subtract 6. And I get y equals 5x, either minus 1 or plus negative 1, either way. Over here, to get the y by itself, I just need to get rid of the 5, and it's right next to it, so I'm going to divide everything by 5. And I get y equals negative 1 over 5x plus 2. Like I said, put that 1 right there so that you know it's negative 1 over 5x, and then 10 divided by 5 is 2. Now they both are in y equals mx plus b form, so I can look at the number in front of the x. And I can say, are they the same, or are they opposite reciprocal, or are they neither? They're not the same, however, they are opposites. One's positive and one's negative. And they are reciprocals, because here I could say 5 over 1, and here it's 1 over 5. So these are opposite reciprocal slopes, so they are perpendicular. Make sure you have all that written down before you move on, including the opposite reciprocal and the word perpendicular. And that's just showing that they multiply together to give you negative 1. All right, number 3, go ahead and write this one down. Y minus 5 equals 8x minus 3. And y equals 2 parentheses 4x plus 1. Again, just like in all the other ones, we're going to have to get the y by itself. So in this one, I'm just going to add 5 to get the y by itself. And I get y equals 8x plus 2. So that one's in y equals mx plus b form. On this side, I have to distribute the 2. So 2 times 4x is 8x, and 4 times 1 is 2. So now these are both in y equals mx plus b form. Now here, this one's a little bit tricky. They do have the same slope of 8, but however they also have the same y-intercept. So these are not two parallel lines, they're exactly the same line, because they do not have different y-intercepts. They have the same slope and the same y-intercept, so we're going to put neither. The lines described by these equations have the same slope and the same y-intercept. So they're exactly the same line. They are not two parallel lines. So write neither for that one. Make sure you have all that written before you move on. You do not have to write this part down here. You just need to write the neither. All right, so there's our first objective, to be able to identify parallel and perpendicular lines. Now we're going to look at some writing equations in slope-intercept form of parallel and perpendicular lines.
Okay, pay close attention to the question here, and then we're going to move over and look at this on paper. It says, write an equation in slope-intercept form for the line that passes through 3, 8 and is parallel to the line described by y equals 2x plus 5. We're going to write down this, y equals 2x plus 5, your point, which is 3, 8, and the word parallel. All right, so our directions asked us to write an equation in slope-intercept form, and you'll notice that the line that they've given us here is already in slope-intercept form. We're looking for a line that is parallel to this line, so we know that our slope is going to be the same. So right here, we're going to write m equals 2, because this is, again, already in slope-intercept form, and it's a parallel slope, so it's going to be the same. All right, the next thing we have to do is use point slope to write an equation in point slope form so we can change it to slope-intercept form. They've given us a point right here. Now we need to plug this into point slope form. Point slope form is y minus y1 equals m times x minus x1. So I have my x1 and my y1. You need to label those on your paper, and then we're going to plug them in. Y minus y1, which is 8, equals m, and m we've already decided here is 2, times x minus my x1 here is 3, So this is in point slope form here. And then I'm going to go ahead and solve for y and get this in y equals mx plus b, or slope intercept form. So 2 times x is 2x. 2 times negative 3 is negative 6. Bring down my y minus 8, my equal sign. Now I'm going to add 8 on both sides. And this is going to give me y equals 2x plus 2. And this is going to be my equation in slope-intercept form of a line with this point that is parallel to this line. So my final answer here is y equals 2x plus 2. Make sure you have everything down that's on this page before you move on. Okay, so we just found the equation to the line that was parallel to the given line. This was our given line. It's graphed for you right here. You do not have to copy down this graph. And then this is the line that we just found that was parallel to the given line. So you can see here that our line is parallel. And again, we have a reminder up here that the lines are on the same plane. Parallel lines in the same plane are lines in the same plane that do not intersect. Sorry, if I could read, it'd be better. And they have the same slope. All right, so for number 5, I'm going to tell you what to write down. It says, write an equation in slope-intercept form for a line that passes through the point 4, comma, negative 2 is perpendicular to negative 2x plus y equals negative 7. I want you to write down the equation. Negative 2x plus y equals negative 7. I want you to write the point 4, comma, negative 2, and then I want you to write the word perpendicular. Okay, so on your paper you need to have negative 2x plus y equals negative 7, the point 4, comma, negative 2, and the word perpendicular. Make sure you have that down before we work this one out. It's just going to be dark. All right, so the first thing we have to do here is we have to solve for y, because, again, they're asking us to get into slope-intercept form, but unlike the last problem where it was already in slope-intercept form, it's not on number 5. So that's the first thing we're going to have to do. We have to solve for y to get it in slope-intercept form. So we're going to add 2x. These are going to cancel, and that's going to give us y equals 2x minus 7. Again, our 2x and our 7 are not like terms, so they cannot be combined. Now we have solved for y. We have this equation, the original equation, in slope-intercept form. So now we are able to identify what the slope of our line is going to be. The slope of this line, the given line, is 2. We are looking for a perpendicular line. This is when that comes into play, okay? We're not looking for a parallel line. It's a perpendicular line. So my slope has to be the opposite and the reciprocal of this slope. So the opposite of 2, which is also known as 2 over 1, is negative 2. And the reciprocal of 2 over 1 is 1 over 2. So it's negative 1/2. That is the opposite reciprocal slope. So go ahead and write m equals negative 1/2. M equals negative 1/2. Now, I have my point, because my point was 4, comma, negative 2, and I have my slope. So I'm ready to plug this into point slope form. Y minus y1 equals m times x minus x1. I have my x1 and my y1, and I'm going to go ahead and plug this in. Y minus negative 2 equals negative 1/2 times x minus 4. And now I can distribute my negative 1/2. When I multiply negative 1/2 times negative 4, it gives me a positive 2. When I multiply negative 1/2 times x, I get negative 1/2 x. Bring down my equal sign. This minus a negative 2 here changes to a plus a 2. So now I'm going to subtract 2 on both sides. and that's going to give me y equals negative 1/2 x plus 0, which could also be written as y equals negative 1/2 x. Make sure that you have all of that down before you move on. All right, so this is a graph of the lines that we just worked out. It says perpendicular lines are lines that intersect and form right or 90-degree angles. They have opposite and reciprocal slopes, and the product of the slopes is -1. So this is what these two lines look like on a graph. This is the line that we found. This is the line we were given. All right, let's have a look at number 6. It says write an equation in slope-intercept form for the line that passes through point 10, 7, and is parallel to the line described by y equals 4/5 x minus 6. Just like the ones that we've done so far, I want you to write down this equation, y equals 4/5 x minus 6, this point, 10, 7, and the word parallel. All right, so on number 6, you've been given the equation, the point, and then we know that we're looking for a parallel line. Those of you that feel comfortable with it right now, I want you to go ahead and take this one and run with it. It's going to look just like number 4. I want you to go ahead and plug this into point slope form and go ahead and solve for a line that's going to be parallel to this line in slope intercept form. So it's going to have the same slope, and it's going to pass through the point 10, 7. Go ahead and pause the video now and try this one on your own. All right, so for those of you who have paused the video and tried this on your own, check your answer. You should have gotten y equals 4/5 x minus 1. If you did not, go back and look at the work and figure out where you went wrong. Those of you who did not try this on your own, please get the answer down and try to make sense of where we did what we did and why. You have your same slope here, and we plugged this in for our m. We have our point x1, y1, and we plugged it all into point slope form, which is given to you here. We worked it out. We distributed our 4/5, and if you don't have a calculator, it's going to be difficult for you to distribute 4/5 to -10. I understand that. That should have given you -8. That is the only place you may have had a question. Again, if you were working without a calculator, it would have given you -8 there. And then you're going to add 7 to both sides. Combine like terms, it's going to give you y equals 4/5 x minus 1, and that's going to be your final answer. Make sure you have all of that down before you move on to number 7. All right, so for number 7, I want you to write down, it says we're writing an equation in slope-intercept form for the line that passes through this point, -3, -2, and is perpendicular to the line described by y equals 3x. So write down y equals 3x. Write down your point, -3, -2, and then write down the word perpendicular. We're going to look at this on paper. All right, this is what you should have on paper, and I want you to go ahead. It's already in slope-intercept form. Determine what your slope should be for a line that is perpendicular to this line. If it helps, I can show you that 3 is the same thing as 3/1. And go ahead and try and work this one out on your own. All right, so if you went ahead and worked this out on your own, you should have gotten y equals -1/3 x minus 3. That is the slope-intercept form equation for a line that is perpendicular to the given line, y equals 3x, and passes through the point -3, -2. You can see all the work over here. You need to get all of that down. You need to check your answers and figure out if you went wrong, where you went wrong, correct your mistake, and get the correct work written down before you move on. Okay, so this covers our second objective for writing equations in slope-intercept form of parallel and perpendicular lines. And tomorrow we're going to complete 2 geometry applications. We're going to do those 2 examples in class. This is the end of your video. Thank you for watching.